Hello and welcome back to our Barnabas Racer class. In this lesson, we are going to continue with an additional navigation challenge. This one, though, is going to be one of your own design, which I'm very excited about. So over the last several weeks, we've been doing these navigation challenges in an attempt for you to get acquainted with your robot. So each of you out there has your own individual robot, and although they all are more or less of the same design, due to small changes in how they were put together, or maybe the motors are slightly different spec than they are on other robots, your robot might not behave exactly the same way as another person's robot would. So I really want us at this point to take advantage of that. We hopefully over the course of the last several weeks doing these navigation challenges have found maybe these small little quirks about our robot that we don't expect other robots to have. So we can actually today take advantage of these things as we're going to be designing our own individual like navigation challenges. So there could be one that is suited to your robot more so than it's suited to any other robot. So over the course of this lesson, as we're thinking through our design for our little obstacle course or navigation challenge, let's just keep an open mind. You guys will have the opportunity to do whichever kind of challenge you want. I'm going to give a few suggestions about things that I might try just to get the gears moving. But you guys are welcome to think way outside of the box. There's nothing wrong with aiming high if it doesn't end up working out, or if it doesn't seem like it's something that your robot can realistically do. You're welcome to just lower the bar a little bit and test again. But I do encourage you guys to think outside the box and just go for it. Okay, so I'm here in Microsoft Paint. I'm using this as my design space. You don't need to do this. You could have just a sketchbook. You could use some other kind of software if you want. I think probably the easiest thing to do would just be pencil to paper. I just thought using Microsoft Paint would help me show you a little bit better of what I would want to be doing. So before I get started drawing anything out on here, I do want to say there are some other quote-unquote simpler designs for courses. My boss, for example, he really likes challenging his students to have their robots make letters of the alphabet. So tracing out like the capital letter A or something like that, and just seeing how far down the list of the alphabet you can go. So you're welcome to try something along those lines. I'm going to come up with, let's say, just two designs here. The first one would just be some sort of maze design, right? So make some sort of course that is going to have several turns. And I think this one might even do, yeah, why not have, I'm going to do this where the robot has to do like go back on itself, right? So I kind of like this because it forces you to do multiple left and right hand turns. So your control over the robot and how it moves has to be pretty crisp in order to do this. And remember that as you keep doing these turns, it may become harder to predict exactly what trajectory the robot will have. So you know that generally speaking, a certain delay gives you like a 90-degree turn. However, after doing several other turns and going through straightaways and things like that, you may have to tweak some of your code a little bit in order to get it to navigate this this kind of course crisply. So I'm just going to make my point clear. Robot goes in here, robot comes out here. So I'm not going completely crazy. I could make a big maze with like lots of turns and like dead ends and things like that. But I want a challenge that I think I could actually realistically and reasonably do over the course of the next couple weeks if I set my mind to it. So this seems like it would be doable. It would be hard, but it would be doable. And I want to keep in mind if I were to make this course that I need to make sure that these walls, which I would probably just use masking tape to create this course. And I want the width to be enough that my robot has some room to maneuver. I don't want it to be literally the lane is only as big as my robot and I have no wiggle room whatsoever. I'd like to have a little bit more than that. So keep that in mind as you're making these courses. And then the other idea I had was actually, it seemed a little simpler at first, but I think it'd be kind of fun. So let's say we've got like some boxes. So I have like 3 boxes here. I'm going to make a very clear delineation here. So this is my idea for course 1. No, stop it. And then here's my idea for course 2. So course 1 is just a little maze type thing. Course 2 is going to be a little bit outside the box. So I'm going to put this, you're not going to fill? I'm going to fill it. There we go. All right. And then we'll go back to doing this. No! Go back. Okay. Fill, solid color, circle. I'm going to put that there again. I'm going to click. Okay. Yes. Paint. I know how to use Windows Paint. Who says I don't? All right. So your robot will start. Ooh, why don't we do this? Your robot will start here facing this way. And then your goal is to get it to land as close as possible to the red dot, which means some point in your code you have to have it stop for an extended period of time. And you want it to stop as close to this thing as possible. If you can get directly on it, that's a bullseye. Good job. So how would I accomplish that? I'd have to I think I would do this I would have the robot go backwards. Then I'd have it turn left. And then depending on how I angle these boxes, I could just have it turn left 45 degrees and do a straight shot, but maybe it'll bump into one of the boxes if I do that. So I'll have it go backwards. I'll have it turn left at a 90-degree angle. Then I'll have it turn right at a 90-degree angle. And then I'll have it stop. And I'll put the delay for the stop as being very large so that I essentially have it just end the code there. So those are my 2 ideas for different courses you can try. Once again, this is of your own design. If you want to just straight take one of the designs that I have given for you here, you are more than welcome to, but I encourage you to come up with your own. I'm very excited to see what you guys can think up yourself. Okay, so while I don't want to give away all of the answers, I thought it might be a good idea to give you guys sort of a preliminary walkthrough of how I would approach doing course 2, how I would get started, and then from there would be a lot of experimenting little by little to get things the way I wanted them. So this is the code that does the obstacle course from last week when we were on multiple surfaces. I put a lot of work into it, so I'm just going to put it off to the side rather than getting rid of it entirely. So I'm going to start by getting subroutines for and just trying to figure out what order I want to be doing things in. So I remember I said I want it to go backwards to start, and then I want it to turn left, then I want it to go forwards, then I want it to turn right, and I want it to go forwards again, and then after that I want it to stop directly on that red dot that I made. So we're just going to do that bit by bit. So let's see what we have. We have backwards, and then after that there is a left, and then after that is a forward, and after the forward is a right-hand turn, and then after the right-hand turn is another forward, and then after that is a stop. So that's just based on the course that I made and how I want how I want to move around those obstacles. For your individual course, if you're doing something different than what I'm doing, you may have a different arrangement of subroutines. Now, of course, don't forget that we need to have delays between each of our subroutines. So I'm going to go ahead and get the millisecond delay, not the microsecond one. I'm just going to clone it a bunch of times. I'm going to do this to make it faster. Clone, clone. All right. And then I want one after each of my subroutines. So I've got 3, 4, 5, and 6. There we go. It's going to be hard to figure out which or what numbers I need in order to make this work out. Now remember, this is just preliminary. I haven't even built this course yet, so I'm just kind of showing you the process that I would go through to get started. I know that the stop needs to stop for a long time because I want it to essentially end there. And then I know that the turns are going to be fairly short because they need to be 90-degree turns. Or roughly 90 degrees. Maybe they don't need to be exactly 90 degrees. I'll have to figure that out as I run this through the obstacle course that I'm trying to make. But this is sort of what I would go with as just, our step one. This is, my best guess without trying it one single time, how I would get the robot to go through the course. So, I will be showing the course off and showing myself tweaking this code here and there in the next lesson. But for now, that about wraps things up. Okay, so that does it for today's lesson. I gave you, as promised, a couple of different suggestions for places you could take this design, this course design challenge, how to make your own obstacle course or whatever navigation challenge you wanted to try doing. I encourage you, if you didn't like the options I provided, to try your own. Go for something new. I'd love to hear if you come up with something on your own that is a little different than what I've done. I'd love to hear about it. Aside from that, just keep in mind that the design portion is very important. So before you get to programming your robot, give yourself some idea, come up with some sort of design, some idea of what you want to be doing with your robot before you just get into ArtibLock and start programming. So come up with that obstacle course or that navigation challenge first, and then move forward with how you then navigate your robot through it. So that does it for today's lesson. I'll see you guys in the next one. All right, bye.